Hi everyone, welcome to my channel. My name is Fikret. This video is part of series on Apache Spark Essentials for Data Engineers. In this part, we're going to explore table level transformations in Spark. As a first exercise, let's take a look at filters. The filters allows you narrow down rows based on some conditions. So in this example, in command 40, I use filter method, and my condition checks if product name is bad, and I have additional condition on top of that which checks if the price of this product above $100. Alternative way of applying filters is to use where clause, which works a similar way. There are some common filtering conditions that it's good to know. So if I scroll down to command 42, here my data frame checks for null condition, and to do that I use isNotNull method, which you can apply on top of call SQL function. There is opposite expression for that, which is called isNull, which you can use to bring only empty values on certain columns. Another useful filtering expression is isIn function. So in this example, I check if my product name is one of these values supplied within the brackets. If you're coming from SQL world, you're probably already wondering if there is conditions which will be similar to like condition in SQL filtering. And indeed, there is a like method here, which you can use to find similarities with some string patterns. And so in this case, I am trying to find all the rows for which product name starts with BE strings. I'm going to wrap up filtering topic with another useful expression, which allows you to exclude the rows matching certain conditions. So in command 45, I am using isIn expression to find all the product with the name of bed and the chair. But if you notice here, I have this tilde expression, which tells Spark to exclude all of the rows matching this condition. So as a result, I have all the rows from my source data except the ones which match this condition. All right, let's move on to explore another category of transformations, which is ordering results. So that's another frequent transformation type. And you can achieve that using order by method. So this method is straightforward. All you need is to list columns, and optionally you can specify ascending or descending keywords. So by default, if you don't specify ascending keyword, the ordering will be in ascending order. So in this example, I order my dataset by product name and sales amount in descending order. Now let's talk about table joins. The table joins requires at least two data frames, and to do that you apply join method on one of the data frames and specify another data frame as an argument. You also need to specify a column on which you want to join, as well as join type. So by default, join will be inner join, but in this case I am specifying left join type. So this is relatively simple syntax for join, and it's applicable when the columns you are joining on has the same name from both sides. So in my example, both product and the sales table have a column name product name. That's why I can use this simple syntax. So let's run this command, and here's the output where you can see columns from both sides. It's important to mention that when you are joining, sometimes you may end up with same column names, especially in the cases when you have same column name from both data frames. To avoid multiple columns with the same name, it's recommended that you apply subsequent select transformation, where you specify which columns from which data frame side you want to output. So in this case, I bring number of columns from sales table, and you can see that some columns like room type and the color are coming from product data frame side. Sometimes columns that you are joining on may not have the same name from both sides. In that case, you can use slightly complicated version of join condition like this, where you specify left part of the join column and the right part of the column with equality in between. The next type of table level transformation I'd like to discuss today is aggregates. Aggregates are very common, especially in the warehousing scenarios where you want to calculate sums, averages, and some other statistical expressions. Just like with other type of transformations, with aggregates you have multiple ways of achieving aggregations. So one of the simplest methods is to use syntax like this, where you add aggregation function to your data frame. So in this case, I am calculating number of rows, which is a very common way of estimating the size of your data frame. The downside of this approach is that not all aggregate functions are available to apply this way. So my next command 54, shows how you can use agg method to calculate multiple aggregates. As argument, you can specify multiple aggregates on different columns. So in this case, I am counting number of distinct names on product name, and I calculate total sales amount and the total quantity. Notice that I also use alias column, and if you don't specify this, you may end up with some weird column names. Now this aggregate we have considered so far, they work on entire table level, but in real life cases you often need to first group by your rows on certain criteria. So in other words, to slice on certain column before applying aggregates. That's what my command 55 does. So you can see that I first apply group by method, and I say group by product name, and then I apply sum function on top of that. So let me show the results. So in this example, I used simple syntax by applying sum. You can also use average or some other aggregate functions. And this kind of syntax is useful when you are calculating only one aggregate. In more complex cases, when you need to calculate multiple aggregates simultaneously, this syntax demonstrated in command 56 is more useful, where you first apply group by followed by agg function, where you can list multiple aggregations functions like we discussed earlier. All right, let's move on to window functions, because that's another type of helpful transformations on Spark data frames. Windowing functions are useful in scenarios when you want to divide your data into multiple groups and apply certain transformation to each group. Command 59 in my notebook demonstrates how to do that. So I'm using with column method here to create row ID column, and I use row number function, which is a SQL function. However, this row number function is applied on different sections of the data called window. So here's my definition of the window. So in this case, I use partition by method of window object or window expression to specify column name by which you want to partition your data first or slice your data first. Then within each group, I assign row numbers. Notice that I also use order by, because once you divided your rows within into different groups or windows, then you need to be specific about how you want to order these rows. So here's the result. So in my example, I created window or section of the data for each product name, and within each product name, I have numbered the rows based on sales amount value. Windowing functions allow you to apply ranking or row numbering functions on top of your data slices. You can also apply some useful functions like lag or lead, which allows you to get values from your previous or subsequent rows. So in this example, in command 60, I applied 3 windowing functions with similar partitioning and order by clauses. So you can see that I partitioned by product name and I order by sales amount. However, in the first case, I use row number function to number my rows. In the second case, I use lag function to bring the value of sales amount from previous row. So notice that my second argument tells how far back the row should be brought from. So in this case, it's just previous value. And the second expression use lead function to get value of sales amount from the next row. So the lag and the lead functions are very good on calculating some financial expressions. For example, to compare your current year to previous year or next year, and so on and so forth. So basically create comparative analysis reports. So let's take a look at the results. So if we take a look here, so this is my sales amount, and the value of my previous sales is 58, which match to this value. So and my next sales is 60. So my data is not great to demonstrate the differences, but hopefully you get that. All right, let's move on to temporary global views topic. When you are applying transformations in PySpark, there's often need to temporarily materialize your results. That could be helpful from multiple sides. One, if you are chaining multiple transformations, sometimes it's easier to assign certain names so that you could easily call it. And the second, materializing allows you to refer to your data frame values from SQL. So let me demonstrate that in command 63. To create temporary view, you can use create or replace temporary view method with the name of views that you want to create. And once you do that, now this object becomes available from SQL. So in this example, I can select from this view just like from any other table. So this is what you can see as a result. Keep in mind that temporary views are transit objects. They are available only within your session, within the scope of this particular notebook it was created from. So once this notebook's execution completes and this notebook is detached, these objects are no longer available. If you want your view to be referred from other notebooks that are part of the same cluster, you can use create or replace global temp view method. However, keep in mind that it will not work if you are using serverless compute. So in my case, as you can see, it failed. But if you are using personal cluster, you should be able to create this global view and refer to that from different notebooks, as long as the notebook that creates it still attached to the cluster and alive. So this kind of views are not permanent views either. If you want to create permanent views that will survive your cluster shutdown, then you need to create views using SQL syntax. I don't have here, but so you can use create view, specify name, and then you specify your select statement as part of SQL statement. And if you follow that path, then your views will be created as permanent object within your data store. So whether it's a Hive store or a Unity catalog, and then you can refer to them anytime. That's all I wanted to cover for table level transformations. Thanks for watching, and I'll see you in the next part.